Okay, welcome to week 4, and this week we're going to talk about unstructured and external data. So I have posted this presentation to the help desk forum. I'll also kind of included this with posting the announcement that I send out to as well. So let's look at structured versus unstructured data first. So structured data, that's more traditionally aligned with big data applications in the data warehousing type of space. So think of that more like the relational databases where most of this data warehousing type ideas and centralized storage of data really started. Now, today's analytics, today's solutions, they are much larger installations, including unstructured data. So some of the characteristics, I would say, if you're going to sort these out in a general sense, some of those characteristics are that structured data has predefined data models. It's usually text-based, not a lot of images and things like that. It's easy to search because it's easy to index. Unstructured data is kind of the opposite. So it often has no predefined data model. It can, although in many cases the data model is very flexible. It may be things like text, images, sound, video clips, all kinds of different kinds of data formats. It can be difficult to search, although a lot of the modern solutions in this space have kind of started to address that. So you can still get enterprise search off of things like images, video, using natural language processing, for example. So there's a lot of things with unstructured data now that they've brought on into the play. Now, typically, structured data resides in relational databases, traditional data warehouses. Unstructured data can reside in applications. It can come from NoSQL databases, which, by the way, start breaking down to about 7 or 8 different categories of NoSQL databases that are out there. It can be in data warehouses. It can be in data lakes. So it's a very flexible type of a format. Now, both of these two could be generated by humans or machines. Some typical applications that would rely on structured data. This is where I'm thinking of like ERP systems, financial systems, CRM systems, inventory control, airline reservation systems. Those are all great examples of things that rely on structured data. Now, unstructured data or semi-structured data, a lot of that would be things like word processing, presentation software, email clients, tools for viewing or editing media. Those are the types of applications which would use and produce unstructured data. Some examples of structured data, things like dates, phone numbers, social security numbers, credit cards, etc. So these are all very transactional in nature. Unstructured data, you'd have things like reports, email messages, audio files, video files, images, surveillance imagery, for instance. So a lot of things could be considered more of the unstructured data. Now, data lakes. So we've talked a little bit about data lakes so far. You've kind of spent some time looking at the architecture of it, talking about some of the specific pieces of it. We talked last week about Hadoop and went into a deep dive of Hadoop. So understand that data lakes are really a design similar to what you're seeing in front of you here, to where you can have the data lake, and then on top of it, you can build data warehouses, you can build data marts off of that, and then interactive reporting on the back end of it too as well. And so here's kind of a visual model continuing on our discussion of some of the stuff that you have in HDFS and the Hadoop system. This is kind of another visualization of that. And as you can kind of see the different types of data coming into the front end of it, enterprise transactional data, which would be more structured data. You could have log files, which would often be semi-structured data, such as JSON, for instance. In this case here, they're using Flume to ingest log files into the HDFS system. You've got web applications that rely on NoSQL databases or various incarnations of NoSQL databases. Those can be connected with a Hadoop connector directly into HDFS to allow you to run MapReduce jobs back against those NoSQL databases. And then, obviously, the explosion of social media applications is producing a lot of streaming data where, again, you could use a tool like Flume in order to bring that into the Hadoop ecosystem. Now, once it's in Hadoop, you could talk about the ETL processing that could be run through batch to then turn around into Hive tables. Those Hive tables could have a structured type of approach to pull it out to build data warehouses on it but you could also use tools such as Spark that we had talked about, and different data science tools which interact with Spark, such as PySpark, for instance. There's also R connectors which do this, to produce some very interesting and interactive reporting. The other thing is, as you can kind of see, you can have structured and unstructured data side by side in the same data lake ecosystem. So it's, again, the advancement of technology from the earlier data warehousing is continued to just evolve. And so this is really some of the thoughts I want you to think about as you're looking at data lakes, you're looking at this particular week. Here's another example of how traditional data warehousing and Hadoop systems can lay side by side. So in some cases, you may already have a data warehouse in place that's dealing with things like the CRM system or the billing system. Those transactional systems can then turn around and produce an operational data store. Now, in future week here, we'll go into a deeper dive on an operational data store, what that is. But those operational data stores, or the ODSs, those can have both Hadoop and data warehousing together side by side. That would allow things like your social media data, your web logs to be collected up inside of Hadoop. And then the traditional systems that are producing that transactional data can be stored inside the data warehouse. Those two could be combined through maybe a Spark job, for instance, out into an ODS. The ODS can be consumed by BI tools. So there's a number of different ways that you can structure this. And very much, as we've also talked about the Enterprise Data Hub approach, Enterprise Data Hub approach uses this same type of technology, where something like a MarkLogic, for instance, or a MongoDB, you can use a NoSQL database to have both structured and unstructured data side by side inside of the same infrastructure. Traditional data lake architecture cast in that same light. We've got, again, just another visualization similar to that. So within this, you can kind of see there's a storage layer, which we talked about Hadoop HDFS last week. Coming into that, you can have real-time, you can have batch, you can take operational data. A lot of things can be stored inside of the Hadoop distributed file system. On top of that, you've got the query layer. That's where things like Spark, Hive, HBase, Drill can come into play. On top of that, you've got your data consumers. That's the applications, the reporting, the dashboards, and the data science efforts. Now, again, we talked briefly about extract, transform, and load. ETL jobs can then turn around and take it out of HDFS and put it into a data warehouse if that's an end target that's required, or it could also be stay within inside of that data lake. Now, I'll also expose you to a couple of different vendors here. This specific data lake architecture diagram that you see comes from MemSQL, and I've also included the links here on the presentation of the various places where I've pulled this information. So MemSQL's approach has kind of a data warehouse type of a feel, a more of a traditional type of data warehouse feel, like a storage layer, a query layer, etc. So again, this is something for you to kind of explore in your studies. One final one here when we're talking about architecture. This is the Azure data architecture. And so within Azure, you can kind of see we have those same type of things. You've got the data storage areas. You've got an actual storage, a staging area which is set up. From that, you can run machine learning. You can run batch queries, interactive queries, real-time analytics to feed over to dashboards. But you can also use that down into defined schemas. And so we can store that data in persistent storage and then turn around and use that for additional trending, etc. So here's just, again, another flavor of what we've been talking about. So let's talk about the written assignment and specifics of it. As we said in the introduction videos, which are also posted, here's a couple different versions of the cloud diagram, which I've showed you, AWS, Azure, and Google Cloud. So as you're going through this, I want you to think through some of those challenges. First question, what are some of the challenges of including external data? So think about this from your solution, but also think about this in general sense. So if you're crossing vendors, so if you have an AWS instance and an Azure instance, there's going to be some specific challenges that you're going to have for using Azure data inside of AWS and vice versa. So crossing vendors, that's going to be one of the things you should consider when answering this question. Secondly, think about on-premise versus cloud. So you may have a data center with all this data included with it, but that could be considered external data to your cloud installation. So if you're crossing between on-prem and off-prem or cloud type of installation, what would be some of those challenges for this external data? And then finally, think about the validation, the quality metrics, the data lineage, ETL versus ELT, some of the different approaches which are there. So these are all part of it. If you're taking data out of an external system and you're going to use this as a replication of the data into your cloud system, let's say, you have to have some validation in place. You have to have some quality in place. You have to be able to demonstrate the data lineage of any transformations that have been done. So think about some of the challenges that could be associated with putting in that kind of a design when answering this question. Second question is explain some of the strengths and weaknesses of storing external data in a data lake. So when you have external data, are you going to, like from a data warehouse, are you going to replicate that data into your cloud? Or are you going to have live connections using an API, for instance, back to your data warehouse? So kind of understanding if you're going to replicate the data, that comes with its own set of strengths and weaknesses. If you're going to have it as persistent storage and make live calls to it, that's a completely different set of strengths and weaknesses. So kind of think about where your data is going to sit. Is it going to sit at a source, like a data warehouse, a transactional system? Is it going to be something that you're going to just replicate up into a cloud instance? Those would be some very different types of challenges as well as some very different strengths and weaknesses. If you are going to replicate it, how often are you going to copy it? Are you going to do that real time? Are you going to do that in batch, etc.? If you think about this, you got to think about this from the requirement standpoint. So if you're going to do this more frequently, that's a requirement that's more heavier on the operational type of reporting or analytics. If you're going to do it less frequently, that's something more on the trending. Or if you're looking at things over time, that's more things that you wouldn't necessarily need real-time updates for. So put some thought to that. When kind of answering the question on strengths and weaknesses, put some thought to those items as well. And then finally, explain some of the differences between storing this type of data within a structured environment, such as a data warehouse, and a more flexible data lake. So if you've got transactional data and you believe that a lot of your activity is all going to be centered around transactional data, a structured database may be a way to go. It could be cheaper for you. It could be quicker for you. So like, for example, an Oracle database storing structured data, that could be a very a good cost point to do that, as opposed to doing this up in a cloud, for instance, where you get charged for transport of that data. So think about, start with kind of the types of data that you have, which solution offers the best, and what's really driving your decision of the storage of that data. Is it something that's going to be driven by cost? You're trying to have a low cost? Are you trying to have a lot of agility? Is there certain capabilities in the cloud that you want to leverage some of those services? Those are all the kinds of things that you could kind of think through when you're answering this question. And again, you can answer this very broadly, or if you have some specific things related to your particular organization or your situation that you'd like to drill down into, either of those two approaches are good. But just wanted to give you a couple extra things here to think through as you're writing that written assignment, as you're answering these questions. If you have any additional questions into that, we have an office hours on Tuesdays here. Feel free to show up to office hours. I'll be happy to field any questions. Or also post these back to the discussion forums, and you can feel free to reach out to me on email. But so far, again, the submissions which we've been seeing so far over the last couple of weeks, individuals are doing very well. Students are doing very well. So I think that you really have embracing the material. You're diving deep on some of this material. So again, keep up that good work. Here gives you a couple of things to think about for this external and unstructured data. If you got any questions, just please reach out. Have a good one. Thank you.